This week we're going to be turning this big hunk of aluminum into a Baja SAE transmission housing and the sister part for next week. This is just the piece of material mounted in my favorite way to fixture stuff, just my Tombstone City rails. There's two serrated jaws on the bottom and the two smooth jaws on the top. The blanks just clamped onto the rails. Here I'm just taking my probe and I'm going to pick up my X, Y, and Z work shift. If you haven't gotten a machine with a probe yet, it's a life changer. You don't have to edge find things and there's no reason to indicate things. It saves so much time for production running and prototype running. You wouldn't believe it until you've actually used one. So after the probing cycle's finished, the first thing that comes up is my 2.5-inch Mitsubishi face mill, running at 300 inches per minute, 1/4 inch depth of cut, and 2 1/4 inches wide. This material is way oversized for what we actually need for this housing. So you're going to see here, I face off a ton of material just to get rid of it, so I don't need to take it off on Op 2. And I just thought it was funny, after it got done running, I'd show the mess that this made and how far it actually chucked some of these chips out of the machine. And just a quick look at the chip bin and some of the chips that it makes. You can tell the 1/4 inch depth of cut. The chips aren't that thick, it's only 7.5 thou per tooth, but the machine was at 110% load, so that's all I could go. Next up, we're just going to pop some 1/4 inch holes here with my solid carbide 1/4 inch drill going 120 inches per minute, and a 5mm drill to pop some 5mm alignment holes. Next up is my 2-flute carbide mill drill. This is just spotting all the holes for the high-speed steel tap drill, and it's chamfering all the holes from the carbide drill. I do this just so that the tap drill doesn't wander because it's not carbide, it's high-speed steel. The next tool up is my 8/66 diameter 2-flute Mitsubishi insert drill. I'd never actually ran this before up to this point, but this is running at 750 surface footage and 7.5 thou per rev. Seems to cut pretty good. After I get the holes popped in there, I come in here with my 5/8 helical 3-flute end mill. This is taking a 1/4 inch width of cut, about 1.25 inches deep, and it's basically just roughing the outside of the part. Not taking a crazy heavy or fast cut because I didn't want to move the part, but it gets rid of the material pretty quick. And a quick cleanup pass around the outside at a lower feed rate just to make the finish look nice. As we start roughing the inside, you'll see the consequence of running an end mill with no coolant in aluminum right here. And that is absolutely not what you want to see pulling your tool out of the machine. The aluminum welded right onto the flutes, way too much heat built up. So I got myself a chisel, chiseled the aluminum out, and finished up roughing the inside of the part. Followed by roughing the next upper step at a way higher step over. I separated this out in the program so I didn't have to have a constant step over instead of just using one 3D adaptive path for the entire part. After that's finished up roughing the part out, we come in with our 332 high-speed steel screw machine drill that I leave in there all the time, just to pop some holes in the outside for clearance. And my way too long 5.5mm drill for the M6 holes. I know this is way longer than it should be, but it was already in the machine from a prior job, and I kind of just figured I'd leave it in there just to pop these quick 5 holes in here. Next up is my standard 1/2 inch 3 flute 2 inch length to cut end mill, roughing out this left bore here. And then I take that same end mill and I start to finish all the insides of the pockets here, just to leave the floor finish better than the adaptive look. I really don't like the look of the dynamic milling pattern on floors, and I always tend to do a 2D pocketing pass. And we do the same thing on the lower step. I believe this is just a 3/8 wide, 3 thou per tooth, 10 thou finish cut, basically just cleaning up the material that the rougher left on the floor of all these pockets. And then the same end mill comes in here and we start finishing all the tight tolerance bearing bores here. You'll see that I basically have the repeat finishing pass on for all these bores just because the tolerances are pretty tight on these and I wanted to get rid of any tool deflection, but it's running at about the same cutting parameters as finishing the floor, but I believe it's 2.5 thou per tooth instead of 3. So next up is another 1/2 inch, 2 inch length to cut end mill, but this time it has 1/8 inch corner radiuses on it. And this is basically here just to walk down this taper at the bottom of the bore to 3D surface it in there. Then we call up my favorite 3 flute helical flute chamfer mill just to add some nice edge breaks and chamfers on the whole part. A lot of the part had large chamfers called out on it, that's why they look so big. And tapping the M6 holes with the M6 form tap. So this is the part off op 1. All the finishes came out pretty good. All the tolerances were pretty much right on. Not really a whole lot of chatter. There's that taper I surfaced in the bottom of the part right there. So take a second and look at this part and think about how you would fixture this for op 2. Keep in mind we only have to make one of them. And when you think of your fixturing idea, put it down in the comments section. I'm interested to see what people say. So my first thought based on the way I wanted to do this was I need some plugs so that this thing doesn't collapse when I clamp down on it. So I designed these 2 plugs in Fusion that fit right into the bores of the part. I exported them into Bamboo Labs. I infilled them at 25% with a lot of wall loops and a lot of loops on the floor and the top. And then I sent it wirelessly over to my new H2S with the AMS that I just got at the end of the year. Hour and a half. And I'm printing out some plugs basically that are going to go in this part just to support the inside of it because it's all hollowed out. So the way that I'm going to fixture this is with my favorite soft jaws. I found some pieces of steel upstairs to use as soft jaws, so I bolted them into my 6-inch vise, measured the material I had, and here I am just putting it into Fusion to design some quick soft jaws. Using the collinear command to make sure the soft jaws are aligned. I'm just dimensioning the size of the material for both sides of the soft jaws here, the spacing of that piece of material I have in the center, which I worked out that would probably be the ideal size for this. And then I'm just kind of roughly positioning them close to the center of the part. And then here I'm actually dimensioning it so that it's perfectly centered. I'm just picking some arbitrary numbers just so they're in a position that I know. And yes, I'm aware AI could probably do this a lot faster than me. I'm doing this manually and I only do this a little bit, so I could be faster, but just extruding the soft jaws up here, making some new components, renaming them, and then I make the sketch visible here, and I'm just going to select all the parts that I projected out, And once they're all selected, I'm going to subtract how high I made the soft jaws from the total height of the jaws here. And as you'll see, I drag them down, then I correct the number, and there's my soft jaws. That's how the part's basically going to sit in there. So I bring the soft jaws into the machine, and again with the probe, I'm picking up the center of the solid jaw, the back edge, and then the top for the Z. And I call up a 3/8 4-flute basic end mill I had. I'm going really conservative with this because I don't want the end mill to pull out of the holder and wreck these jaws. So this took a little bit to do, but I just kind of walked away and let it run, and it basically finished it out without any issue. I see a lot of people that make soft jaws that don't finish the floors on them. I always find I have flatness problems when I don't do that. So here I'm just doing a 2D pocketing pass that basically finishes the floor from the dynamic milling path. That way it's actually completely smooth and it doesn't have that wavy finish on it. And a quick look at the finished soft jaws before the part goes in. So here's the part again off op 1. I put my plug in there. I decided the other plug probably wasn't necessary just because it's so thin there. It really wouldn't do a whole lot. So with the plug in there, I put it into my soft jaws and tighten the vise down. See there, making full contact all the way around the profile. And we can start our machining operation for op 2. This is quite a bit lighter than op 1 just because of how it's held. It's going to actually get pretty thin. So this is only 150 thou depth of cut instead of 250, and 1.5 inch width of cut instead of 2 1/4. As we get closer to the bottom here, you can already start to hear the resonance from the part getting thinner. So because it's always a bad idea to take top hats off unsupported material with a face mill, I come in here with my 1/2 inch, 2 inch length of cut chip splitter end mill from Helical with a 30 thou radius on it. And this is basically just doing the rest of the roughing that the face mill would have done if I would have went all the way down with it. And then after the top hat's gone, we take that same end mill with a rest machining and rough the rest of the top of the part off, including all the steps that are going to get put in afterward. This tool is going quite a bit slower than I would normally run it, but just given how thin the part gets, I really didn't want it to get ripped out of the jaws since I only had to make one of these, so the speeds and feeds are pretty conservative on this. Next up is my 1/4 inch end mill, just boring out these counter bores on the top of the part. I believe these are a 4-degree ramp angle, and you don't really have to worry about it chip welding because all the holes are pre-drilled. So after I get done ramping all these, I use that same 1/4 inch end mill, do a quick rest machining op on this boss here that gets the triangles machined out, and finish all the walls. And after that's done, up comes that 1/2 inch, 2 inch length of cut finisher again, first finishing the center boss right here. And then we move over and start finishing all the rest of the diameters along with that small top of the boss on the opposite side. So because there isn't really any tolerances on anything that's tight on this side of the part, I'm basically just doing all these finish passes for cosmetic reasons, just to give the part a nice finish when you look at it. It's pretty much all running at 3 thou per tooth with a 3/8 step over, roughing and finishing all these different steps all over the part. After that's all finished up, in comes my 30-degree mill drill just to put a lead-in chamfer on this bearing boss. So next up is my 1/4-inch ball end mill here. It's just a 3-flute ball end mill from Helical with a 2-inch relieved neck on it. And I'm going 17,500 RPMs to start here, but you'll hear in a second, I really don't like the way that this starts cutting. It chatters way too much for me. So you'll hear that I start playing with the RPMs here to try to get rid of that. Now, it doesn't sound amazing, but given the amount of stick out on this tool and the fact that it's taking a 50 thou width of cut, I was pretty satisfied with where it was there, so I left it. So before I do any surfacing, I almost always run a 3D adaptive with the same tool I'm going to surface with, just so it doesn't gouge into any material and wreck the finish. So you'll hear there that I actually did the same thing on the finishing pass as the roughing. I ended up lowering the RPMs down just so that it sounded better when it was cutting. This is doing all the surfacing right now, so I wanted the finish to look decent. Given that it's a 10 thou step over, it would be a little scalloped, but I just didn't want it to be chattery when it was done, because it's pretty much all cosmetic. After we're done with what felt like an absolute eternity of surfacing, we got to go back and, of course, add edge breaks to everything I can get to. You know how much I love my chamfers. And after that's finished up, here's the finished part in the soft jaws before I've removed it. All the finishes came out pretty good. That middle boss definitely could have been better, but I wasn't going to go back and redo it all again just because of that, given that it had no functional purpose. And here's the part outside of the jaws, just for a quick look of what it actually looked like when it was finished up. I'd say 8 out of 10 happiness with how this came out in general. I hit all the tolerances, so I felt good about sending it. So as far as the fusion goes on this part, pretty easy. Stock modeled right here for Op 1, my probing cycle. This is just my facing pass with my face mill. See here, 1/4 inch depth of cut, 2 1/4 inches wide, just roughing all that material off, drilling all the holes. Some of the retracts are set higher, didn't really care that much, really didn't add any significant time. This is the 5/8 roughing pass here. You can see the feed rate, the width of cut, leaving the radial stock just for my finishing pass. And you see here how I kind of split this up into different 2D adaptives instead of leaving it a 3D adaptive. I wanted it to have a different step over for each pocket depth, so it didn't waste so much time taking the same width of cut when it could take a way heavier one, and I didn't want it to take too heavy of a width of cut when it was taking a full depth. So just the rest of my spot drilling, roughing out that one pocket that I showed, the containment boundary selected around that pocket, and just kind of showing here the lighter width of cut and depth of cut, just because I didn't really have to be that aggressive. It wasn't that much cutting. Same tool with my 2D pockets, finishing everything right here as you see. And then that end mill with the 1/8 inch radius on the corner. My spiral tool path here that I had. There's my feed rate, my cut recipe for that. You'll see there I selected as the model the angle I was trying to surface with the radius at the bottom. My heights are basically driven off where I didn't want it to go above. That was mainly to just get rid of the whisper cuts when it was running. And then you see here the rest of my edge brake chamfers and the finally tapping the M6 holes. So as we jump into Op 2 here, you see everything got ungenerated because I accidentally changed something in Operation 1. But as you see the spiral path here, pretty smooth. No actual whisper cuts that it jumps around on. That's my biggest pet peeve with toolpaths like that. So you got to make sure you have continue rest machining selected here. That way it doesn't cut any unnecessary material from Op 1. As you see here, my soft jaws. I actually set my work coordinate system as the same as when I machined the soft jaws. So I didn't have to pick anything up. I just loaded the part in and went. So my 3D adaptive from Op 2, showing the cut recipe, how it's just a little bit lighter than what I was doing on Op 1, just so I didn't move the part. And finishing that top boss, the 3D adaptive path with this 1/2 inch end mill. See here again, lighter width of cut than Op 1, just keeping the cutting pressure down. And I split it up so that this was a 2D adaptive separate from the 3D because I wanted a bigger step over again, save some time. Boring out all the counter bores with the 1/4 inch end mill here. You see again my ramp angle. I always do repeat finish passes just to leave a good wall finish. My 3D adaptive here, this just roughs out basically the angle on the top of that through bore and those triangles on the outside. Set my height as the lowest point on those triangles, and there's the roughing and finishing. Finishing the face there, my bosses, all the diameters. These are all just basic 2D contours, 2D pocket passes just for the finishes on there. See the lower feed rate than the roughing. Pretty modest step over. Didn't want to go too crazy again. And you see here, I actually selected the outside of the part as the stock contours. That way it doesn't actually overcut. It only cuts what's left. Same 2D pocketing passes for the outside. And then a bunch of contours just to finish up all the walls. Basically just make sure everything's finished on the part. Then we come in with that chamfer mill with the 30-degree chamfer. Then you'll see here my 3D adaptive with that ball end mill. Like I said earlier in the video, I always do this just because it mitigates having any gouging or any sudden material that the ball wasn't expecting. So I actually used a scallop to finish all these. You see the relatively coarse step over here. And the way that I actually drove this tool path here is I selected the jaw as the height so that it didn't gouge into the top of my soft jaws. I did a relatively small step over, and then you'll see here I actually selected all the radiuses here as touch surfaces, and I changed the model surfaces to a void with a tolerance on it of how far to stay away from them. That made the tool only machine what it had to. Then as you see here, the 3D adaptive, it just kind of jumps around, gets rid of all the stuff that was still there from the 1/2 inch tool, and that's pretty much finished. Nothing too complicated. So stay tuned next week where I turn this even bigger piece of material into the mating part for the other side of this transmission housing. And as always, thank you for watching, and I'll see you in the next one.